All right. So we're going to focus today on an atom and how they move and the math involved, which lets us do our lab that we're going to start making the chemicals for tomorrow. So I'm going to just focus on one single atom to start with. If I have a single atom, it doesn't matter what element it is, we're just talking about an atom. When all the electrons are in their normal, or I could say correct location, which would be the right energy level. That's called ground. Ground state. So when every electron is where it's supposed to be, I haven't done anything to make them change. That's called ground state. So if I take something really easy, like lithium, that would be lithium in its ground state. Yeah, everybody's where they're supposed to be. Now what we often do to different atoms to get, to produce something that we want, is we add energy to them. And when we add energy to an atom, it causes them to change. Okay. So sometimes we add energy to the atom. And when we add energy to the atom, something really cool happens. Isaac's too loud. When we add energy, okay, how many of you have seen a neon sign? You know what I'm talking about? When you look at a neon sign and it's not plugged in, it's really boring. When you plug it in, what does it do? It does this. It glows, right? It gives off light. So we can take different chemicals, different atoms of different chemicals, and we can add energy to them, and they do all kinds of cool things. So when we add energy, you're going to see the different colors we can make in lab. I'm going to say when energy is added, the electrons become excited, and they jump energy levels. So they're sitting at their normal energy level. We add some energy, they get excited, and they jump up. They sit there for a minute, and they fall back down. And we'll talk about what happens when they fall back down, because it's pretty cool. This energy is normally in the form of heat. That's what we're going to use for electricity. The light above your head, if you have one of the bulbs above your head, that's just a stream of electrons flowing from one ballast to the other, or from one end to the other. They're just moving along, and as they move along, the energy creates light. That's a simplified version of it, but that's basically what happens. So when the electron moves up, and it jumps up to different energy levels, and that's called excited state. So ground state is where they normally are. Excited state is when they've moved up, gone to a higher energy level. And we're going to kind of make a little diagram here and look at how that happens. So, I'm going to draw the nucleus of an atom. And I'm just going to add, I'm just going to add 2 energy levels. We'll stick with lithium. This will be lithium. And underneath lithium, I'm going to have a flame. So there's some fire. Heating it up. I'll make it hot fire. Put a little glue in there. So that's basically the flame from your Bunsen burner. So this is actually the energy added. And then I'll just put my 3 little protons in here. I'm going to put my electrons up here. So there's my lithium. And I will work with this electron. And where it sits right now, I would say it's in ground state. So that's where it's supposed to be. And then I'm going to add energy. And when I add energy, my electron jumps up. So I've got excited state now because it's jumped up. When it sits there for just a second, or maybe longer, it depends on the chemical, depends on how many electrons are jumping. You'll see in labs some of these last much longer than others. The ones that are pretty long most of the time have a higher atomic number. There are more electrons to work with. There are more electrons to excite. Then, and I'll write this out here. The electron falls back down to original level and gives off light. That's exactly what's happening in a light bulb. It's exactly what happens in a neon light. It's exactly what's going to happen when we do flame tests. You'll see that all these different metals that are in groups 1 and group 2, they all produce different colors. How many of you have seen fireworks? Probably everybody in this room. That's exactly how fireworks. That's how you get the color in fireworks. By using different chemicals. Like I know what color or what chemical I want to use if I want to make a red firework versus a green one versus those ones that are like clear and sparkly. Got all the stuff back there to do it. Yeah. When it moves down, on the way down, it absorbs energy on the way up, so stores up the energy. Then when it falls down, it gives it off in the form of light. So what you'll see when we do flame tests is you won't see the electron jumping and falling down. You'll see it on the wire, and it'll be whatever color the chemical is in its liquid state or its solid state. And then when you put it in there, it's going to glow maybe a totally different color than what you're seeing in your beaker test tube. Yeah. It will until, like, for us, we're gonna burn off all the chemicals. But if you had an endless supply of chemical, they would just keep jumping up and down, up and down. It's like a cycle, just like a light bulb, until something goes wrong, like your filament breaks, because there are some elements in the filament, like tungsten. And how many of you live out in the country? How many of you have a barn? How many of you have a like an outside light for your barn? What color does that glow? Have you ever paid attention? There's two different kinds. Which yours, Lucas? Yeah, like motion, but yeah. Okay, there's a white one, and what's the other one? Anybody have the other one? Like we have, they stay on a little longer. They're yellow. They glow sort of a yellowy color. That's called a sodium vapor lamp because there's actually sodium gas in there, and sodium, when it is excited by adding energy, is sort of a yellow-orange color. So when you see that haze, so that's because of the gas that's in there. Now, you can't like think because, oh, it's glowing red, it's got something, you know, they make red and green and blue light bulbs where they're painted on the outside. That's a totally different thing. Okay, all right. Now, a couple more terms, and then we'll do a little bit of math, and then we're going to stop. So we say, when the electron falls back to ground state, it gives off energy in the form of light. One electron gives off what is called one quantum of energy. So a quantum is the amount of energy one electron gives off when it falls back down. And that is equal to one photon of light. And a photon is just an energy packet of light. So those are two different terms. One quantum equals one photon. If I have two or more electrons doing this, then it's called a quanta of light. That's more than one. Quantum is singular, quanta is plural. It seems backwards to me, but. So one packet of light is a photon. My electron falling down and giving off light, we say it gives off a quantum of light. If it's two or more giving off the light, then it's quanta of light. So all of this stuff really has to do with light and electrons. And when we work with light and electrons, it's called the dual wave particle nature of light. Basically, all that's saying is light has characteristics of waves and characteristics of particles. Particles being like the subatomic particles, the electrons. So light's caused by the subatomic particles, the electrons.
students that eat in the lunchroom or in gymnasium, please use blue section of bleachers only, both the home and visitor bleachers are not working properly, and we would like for everyone to stay off of them at this time. Again, please set in the blue crew section today if you are eating in the gymnasium, and please try to be spaced out just a little bit. Thank you.
All right, so lights caused by subatomic particles, we already said it's the electrons moving and giving off energy. That's where the particle portion comes from. The wave portion comes from the fact that energy from the electrons travels in waves. So light is caused by electrons giving off energy that travels in waves. That puts it all together. That's exactly what you're going to see tomorrow in lab. Well, probably not tomorrow. You're going to make your chemicals tomorrow and make your daily tables and stuff. And Friday and Monday we'll try to look at it in lab. All right, so I'm going to draw something. I'm going to give you a little quiz. See what you remember from old Mrs. Weber. Oh. I think you'll do better than you think. You don't know what the quiz is yet. Okay, I'm going to draw a line this way. And then I'm going to draw a series of waves. Do the same thing with your notes. It doesn't have to be that big though. Draw yourself a series of waves. Got a series? I'm going to let you have the brain power of two people. It might be as good as your own, and it might not be as good as your own. We'll see. Between the two of you, and I don't really care who your two people are, I'm going to give you 2 minutes. That might be too long. We'll see. I want you to label everything you can on that wave series. Go. Find a person. Or if you think you're smarter than everyone else, work alone. I don't care. Got 2 minutes. What have we got? 4 brains over here? I'm going to add one thing that I want you to put on your diagram. I don't think anybody probably put this in here. Put that on your diagram. That little square. You might not have even had that little square before. Sometimes it's a line, sometimes it's a circle. You got 4 things? No. 2, okay, that's better than 1. Maybe, if they're right. Oh no, there's more than 4. I was just seeing. Okay, let's go. Let's talk about this. I don't want to run out of time. If you don't have them enough, just fill them in as we go. Or if you have them wrong, fill them in as we go. All right, so if I put a mark right here. Ooh, Drake, you were first. What is that?
Yes.
That is a crest. Can you define that for me?
It's the top of the wave.
Okay, I'm gonna say it a little differently, not that you're incorrect. I'm going to say it's the highest point of a wave. Okay, so what else should y'all have gotten? I'll put one down here too. You already gotten that one. Yes, that is a trough. Good. Which is the lowest point of a wave. Everybody get those two? What you got, Shelby? Amplitude. Where is amplitude? Amplitude, actually, I'm going to draw, let's see, I'll draw a green line. Amplitude is right here, from the crest to what we call baseline. So this line right here, we probably should fill in. This is baseline. Anybody have that on theirs? No? This is a line of reference. We're going to say for wave comparison. So this is amplitude. And basically it tells the size of the wave and it is the distance from baseline to crest. Or I could do baseline to trough. And they should be the same. In perfect ideal situation. What else do we have? Yes. Good. So here to here. I'm going to call this wavelength. And that is